Good morning, everyone. Welcome to Intermediate Microeconomics, Econ 301. This is week 1, lecture 1, introduction, basic mathematics concept. So in today's lecture, we are going to review some basic concepts in math. We're going to use some mathematical models to facilitate the discussions in this particular course. This is not a mathematics course, but mathematics will be used to facilitate the discussion for most of the topics that we are going to deal with. Topics ranging from consumer behavior to producer behavior, producer theory, the strategic interaction of firms, perfect competition and monopoly, oligopolistic competition, etc. So we're going to be using mathematical concepts to facilitate the discussions in each of these topics. So I encourage you guys to review some basic algebra. I've made fundamentals of mathematical economics available. If you are able to get that particular book, I think it will be useful for this particular course. So I need you guys to look at some various models in economics, demand and supply model, and the perfect competitive market situation. And then you also look at some basic functions like the algebraic as well as the non-algebraic functions. So in particular, we are going to use both algebraic as well as non-algebraic functions in this basic math review. So let's go ahead and get started. So this lecture is divided into 3 basic concepts: mathematical models, simple algebra, and calculus review. In the basic concept, we're going to look at different types of functions, polynomial, transcendental, as well as exponential functions. We're going to look at both the algebraic as well as the non-algebraic functions. And then we'll move on to simple models, demand and supply models, consumption models, etc. So models are normally used to simplify an actual situation or reality. Now, we have a lot of complex economic processes that are so difficult to explain. So sometimes we try to use a simplified framework to explain or to illustrate those complex economic processes. So that is precisely what a model is. So we're going to be using different mathematical models. Example, we have the simple demand and supply model. You have simple production function, etc. And we also have some other logarithmic as well as exponential functions. So the logarithmic as well as the exponential functions are a form of transcendental functions, or in other words, they are non-algebraic functions. So we're going to be looking at all those ones in this particular course. So in this particular course, we are going to use mathematics as a tool to illustrate some complex economic concepts. So here we're going to look at economic models And some of these economic models are expressed as algebraic as well as non-algebraic functions. Now, for algebraic functions, we use algebraic operations to represent those ones. For example, we have the demand function, which is given as QD equals to A plus BPD. Now, remember here, we are using variables. When we talk about algebraic functions, we are using variables. We are using algebraic operations to represent those particular functions. For non-algebraic functions, we are using non-algebraic operations to represent the non-algebraic functions. And one particular example of a non-algebraic function is the transcendental function. We're going to look at this one later on in this discussion. Now, what is a model? A model is just a simple framework that is designed to illustrate complex economic processes. So, we want to illustrate some complex processes, economics. We use a simple framework, and that simple framework is known as a model. Example, you have a simple demand model, you have a simple supply model, you have a reduction function. So in most models, we use both algebraic as well as non-algebraic operations to represent the models. Now take for example, a simple linear model, a demand model, which is QD equals to A plus BPD. Now, A and B are just parameters, and the parameters can either be autonomous or they can be constant. And we also have variables. Now, for the demand model, which is QD equals to A plus BPD, the P and the QD, these are all variables. So variable as a result refers to just any entity that can take different values. For example, you have income, household, you have the population of a particular country, you have the revenue, you have the price, you have wages. These are all expressed as variables. Now, what is an equation? An equation shows how one variable behaves in response to changes in the other variable. Now, for every equation, you have both the dependent variable as well as the independent variable. Now, the independent variable determines the dependent variable. So as a matter of fact here, if we look at this simple model here, the demand model, the QD there is endogenous, and then the PD is exogenous. So the exogenous variable here is the price. Now, the constant term there, which is the autonomous term, is A, and then the parameter is B, which is the slope of the line. This is a straight line. This is a linear demand or linear function. It has a slope, and the slope is negative because the relationship between demand and price is inverse. If price increases, the price of Colgate increases, you expect people to buy less Colgate. If the price of Colgate decreases, you expect more people to buy Colgate, vice versa. Now, We also have certain definitional equations. Um, some of Now definitional equations are sometimes represented as identities. Now, if you look at the profit function, now the profit function is just the difference between total revenue and total cost, right? So profit is just equals to TR minus TC, which is an identity. And now if you also look at the savings investment equation, you have savings equals to investment. It is also a definitional equation. Because this particular equation is set up as an identity. Now we have behavioral equations that we're going to be looking at. Take like, for example, the simple demand equation. That's a behavioral equation. In the sense that it shows how one particular variable behaves in response to changes in the other variable. Now, if you look at the demand function that we discussed earlier on in the previous slide, that QD equals to A plus BPD. Now, you see how the quantity demanded behaves as in response to changes in the price. Now, if the price goes up, then the demand is going to fall. If the price goes down, the demand will increase. So demand and price move in opposite direction. As a matter of fact, the quantity demanded respond to changes in the price of the good. So if the price increases, the demand will respond to that increase in price. Same thing happens when the price falls. If the price falls, demand is also going to respond to the change in price. So that is a behavioral equation. It shows how one particular variable behaves in response to changes in the other variable. Now you have a conditional equation. Now, certain equations are conditional, which means that certain requirements must be satisfied. Now, take for example the equilibrium condition, or maybe you look at the equilibrium condition of the farm. Marginal revenue equals to marginal cost. That is a condition that needs to be met. Same thing, quantity demanded equals to quantity supply. In equilibrium, quantity demanded equals to quantity supply. That particular requirement must be satisfied. So these are all referred to as conditional equations, because for this type of equations, a requirement must be satisfied.